Hi. So today we are going to talk about indefinite integrals and that too, how to solve integration by maths. So let's get started. First up, you must be aware of this term, calculus, right? One of the greatest inventions of mathematics, right? This calculus has a contribution and was developed independently by two mathematicians, Isaac Newton and Leibniz, in the late 17th century. You can go and check them out, what all they have done for the contribution of calculus. But basically, what we have known so far is differentiation, right? Newton used it, the calculus, to explain motion, whereas Leibniz introduced this integral sign. So integration, we can say that, okay, he has given this integration sign, but what exactly integration is? Do you want to know? Okay. Let's say I have a function as 2x. Okay. Now you already know that. Can you tell me what is the derivative of 2x? That's correct. It's x squared, right? So derivative of x squared is actually 2x. So can I say if I take this d by dx onto other side, it will become integral sign. And this will give me x squared. And because I know if I would be having, let's say, x squared plus 2, then also its derivative would have been 2x, x squared minus 5. Again, the derivative is 2x. So if we want to have that exact function, because the differentiation of constant is 0, that's why I need to put this arbitrary constant here. Okay? And this is called as constant of integration. Okay? So what have you seen here? If a function f is differentiable and there must be an interval where it is differentiable, that interval, let's say I, and its derivative f dash exists at each point of I, then how can I get, if f dash is given to me, how can I determine the function whose derivative it is? So we have seen if function is given to us whose derivative is given, and I need to find out back the function itself, then what are we supposed to do? We can simply do integration. So this is the back reverse engineering which we are doing. So here, this 2x is the derivative of the function. Which is given to us, and we have found out x squared with the integration constant. This is what we call primitive of the derivative or the original function. So can I say that integrals are nothing but antiderivatives? Because what we are doing, this is a process of going backward from derivative to the function, the original function. Hence, integration is also called as anti-differentiation. And because we don't know exactly what constant it is having, so we can also call it as indefinite integral. Okay. Now there are many significance of it. So if you want to know, Let's say you are given a function of instantaneous velocity. Okay, that is the velocity of an object at any particular point. Let's say the function is t square minus 3t plus 2. And you want to find out what is the position of the object at any instant. Then what would you do? You simply take its integration and you know how to solve it. You add one power if it is an algebraic expression and you divide it with the same. And again, this is 3t raised to power 1. So 1 is added, divided by the same. Here I can say that it is 2t raised to power 0. So 1 is added and that is divided. So this is my answer. And I'll, of course, be having an integration constant. If the limits are given to me, let's say 1 to 2, then I would be putting them down here, final value minus initial, right? That was simple. You know about it. But what about, have you ever wondered that how to integrate when two functions are given and the operations between them is actually multiplication? Can we do that? So let's see. Let's see if we can do the differentiation of product and then find out the integration from it. Let's say I have uv as a product of two functions. And I know the differentiation as per the product rule is one function as it is, differentiation of other, plus another function as it is, differentiation of next one, right? So if I have to find out, let's say this, it will be what? You will take this to another side. It will give you minus of dtu by dx, right? Now, if you do integration with respect to x, so here you have dx, here you have dx, here you have dx, correct? Because integration has integral symbol along with what you want it to be integrated with respect to, right? So now you can see that this is gone. So you are left with u dv, and then this is gone. Then integral sign with duv. This is also cancelled. Only uv is left, and here you have dtu. Yes or no? So can you see this is the formula when you want to do the integration of products of function. That is called as integration by parts or integration, partial integration, okay? How do we do that? You can see that here are two functions. One will be considered as first, another will be considered as second. Now you might be wondering, oh my God, how do we calculate or how do we assume which one is first, which one is second? So there's a mnemonic for it, and you do it as I late. Here I stands for inverse trigonometric function. So whenever you see inverse trigo, sine inverse x, cos inverse x, just consider that first function. Then logarithmic, log, algebraic, x square, x, y, then trigonometric function, and then exponential, okay? Now, if you see, I need to do this x sine x. Which function I need to consider first? This is, of course, algebraic and trigonometric is given. So the priority will be given to algebraic. So first function, second function. What is the formula? It is first function as it is, integration of second minus derivative of first function integration of second function and its whole integration. Okay, so this becomes x. You know, integration of sine x is minus cos x. Then differentiation of x is 1. Integration of sine x is minus cos x. And again the integration. So this will give you integration of cos is sine. So this is the answer. Plus c. Got it? So let's try p by q. So there's one question in which you have to find out the value of integration of e raised to power sine x sine 2x dx. How can you solve that? Firstly, I know two functions are sufficient, but here exponential is given, sine x is given, and then another theta. How would we solve that? Can we expand sine 2x as 2 sine x cos x using the trigonometric identity? So this will become e raised to power sine x 2 sine x cos x dx. Correct. Now let's try substitution. Let us assume sine x as u, and if you differentiate, it will become cos x dx as du. Correct. So this has become du e raised to power sine x, we have assumed u, sine x u. That's it. Now you can see that this has become as if the product of the function. So but I late. Exponential comes last. So first function as it is, integration of second minus first differentiation of first, integration of second, and with respect to u, and the whole integration, right? So this gives you u, integration of e raised to power u is e raised to power u, differentiation of u is 1, integration of e raised to power u is e raised to power u, and again. So this gives you u e raised to power u, again integration of e raised to power u is e raised to power u, you can plus c. You can take e raised to power u common, u minus 1. Now substitute back the value of e raised to power u. U is nothing but sine x. So this becomes 2 e raised to power sine x minus. Is it clear? Plus c. Don't forget to put the c, because you know that in differentiation it is constant and differentiation of constant is c. But we need it in the function. Alright, I'm hoping that you've got it. See you next time. Take care. Bye-bye.